Now that we have one tool in our toolbox, the multiplication principle, we can start answering some questions that are not quite as straightforward as the one we just did with the die and the quarter. So in this situation, it says Jen, Patty, and Nicole are to be seated in 3 seats at Fenway Park. How many outcomes are possible? So by outcomes, obviously, we mean how many arrangements of the people Jen, Patty, and Nicole in those seats. So, for instance, here are the 3 seats in a row. We could have, Jenny sitting first, and then Patty, and then Nicole. Or we could have, Nicole, and then Jen, and then Patty, etc. So at this point, listing all the possibilities it's okay, but it's not ideal. And of course, we could make a tree diagram too, but that becomes less practical the more complicated your problem becomes. So the better way to view this is to use the multiplication principle. So what I mean by that is, here are my 3 seats, right? Seat 1, 2, and 3 in a row. So just think about filling each seat individually. How many ways can you fill this first seat? Well, at the beginning of the situation, there are 3 options for the person who can sit there: Jen, Patty, or Nicole. So there's 3 ways to fill that seat. So now that seat's filled, we have to fill the second seat. Now, since we've already filled the first seat, there are only 2 people left to fill the second seat. So the number of ways to fill the second seat is 2. And then, finally, there's only 1 person left to fill that last seat. And so there's 1 way to do that. So the way to view a problem like this is to view it as sort of 3 different events, all making up this one big event. So the number of ways to fill these 3 seats is the number of ways to fill the first seat times the number of ways to fill the second times the third. And you can see that's 3 times 2 times 1, which is 6. Now just a little note. So this is, of course, 6. A note: when you're multiplying a number times, or an integer, I should say, times all the integers below it down to 1, that's called factorial. So for instance, 4 factorial is equal to 4 times 3 times 2 times 1. 5 factorial is equal to 5 times 4 times 3 times 2 times 1, etc. So factorial in general n factorial is the number n times the 1 below it, which is n minus 1, times the 1 below that, which is n minus 2, n minus 3, all the way down to 2 and then 1. So there's just a definition of factorial. Let's look at the next problem. And how many ways can you arrange the letters A, B, C, D in a row? So one of the things you want to keep in mind is that there are different problems you can ask, but most of them kind of map on to a previous problem you've already done, often. So for instance, that problem we just did about arranging three people in a row at Fenway Park, this problem is pretty much exactly the same, except rather than people we have letters, and instead of 3 of them there are 4 of them, but arranging the letters A, B, C, D in a row, and again, one arrangement would be something like, B, C, A, D, and then of course there's like A, B, D, C, etc. Right? We could list them all, but it's better to think of it as 4 slots for each of the letters, 4 ways to fill the first slot. Once that's full, there's 3 ways to fill the second, and once that's full, 2 to fill the third. Once that's full, just 1 to fill the last one. So the answer to this question is 4 factorial, which turns out to be 24. Okay, so once you sort of buy into this whole multiplication principle, you do a tree diagram once or twice so that you understand that what's really happening is that you're just multiplying by these, you're multiplying these separate events together. You no longer need to make those tree diagrams, and you can answer a lot more questions. So the last one we're going to look at is slightly different, and so we're going to end with it. here it says 2 identical calculators, an advanced math book, and a ruler are to be placed in a row. How many ways can you do this? So this problem is a little bit different than the 2 before, and the reason is because of this. The fact that you have 2 identical calculators. Let's represent them with letters. So 2 calculators, let's say calculator C, C, and then you have an advanced math book, we'll label that with an A, and then a ruler, we'll label that with an R. Now, if these calculators were different, let's say this is like calculator 1 and calculator 2, and let's make it a different color. Let's say it's, just to keep things, let's pretend that those 2 calculators were different, basically like they're different letters. Then we know the answer would be 4 factorial, right? Just because it's the same problem as the one on the last page, A, B, C, and D. Now the problem is that those calculators are not different, right? They're actually the same. And so what's going to happen is if you were to list out all your possibilities, so this isn't actually so bad. I'm gonna list them out here. If I list out these possibilities, I would have something like calculator, and then advanced math book, ruler. I could have calculator, ruler, advanced math book. I could have calculator, advanced math book, calculator, ruler. I could have calculator, ruler, calculator, advanced math book. I could have calculator, advanced math book, calculator, advanced math book, calculator, ruler. I could have calculator, ruler, calculator, advanced math book. I just listed those. That's not what I meant. What I meant was I could have calculator, advanced math book, ruler, calculator. I could have calculator, ruler, advanced math book, calculator. So I'm trying to be somewhat systematic. I have this 2 C's at the beginning, 2 C's, a C at the C in the beginning, and then the middle position. I could have the 2 C's in the middle, C, C, and then I could have an advanced math book, ruler. I could have ruler, calculator, advanced math book. And I could have the 2 C's at the end. I could have these 2. And then I guess lastly, what am I missing here? I think I just need calculator and rulers, or calculators in the 3rd and the 4th position. So I think that is everything. All right, and basically the way I did it was I kept, so like this is all the ways with the calculators in the beginning. This is with one in the 1st and the 3rd slot, etc. So there's only 12, and so we've overcounted here. Look up at our answer, 4 factorial. That's too much, right? Because that's 24. The answer really is 12. These are all the possibilities below. We went through them systematically, and there's just 12. So we've overcounted. Now here's the thing. How can we overcount it? Well, because if I'm to pretend that the calculators are different, then what I would have had to have listed would have been this. Right, here's calculator. Let's just say this first example here. This would be calculator 1, and this could be calculator 2. Then this could be calculator 1, and this could be calculator 2. But I also would have had to have listed these ones too. So I'll list them above here. I would have also had to have listed the ones with the calculator 2 first and calculator 1 second. I didn't list those because calculators are the same. So this 4 factorial is going to count each of these 2 double blocks twice. It's going to count each of these twice, right? Just like that's listed up here. But we actually don't want these two up here because it's the same arrangement as these two down here. So what we have to do is we've got to divide our 4 factorial by 2. And now it's, for reasons I'm going to explain later, it's not really just 2, it's 2 factorial. Because the amount of duplicates is equal to the amount of ways to arrange these C's. So if there were 3 calculators, we would have expected that each of these arrangements would have been set up 6 different times, 3 factorial times, 1 for each way to arrange those C's. Okay, and so I'm going to end it here, but this 2 factorial is number of repeated C's. Okay, so this answer is 4 times 3 times 2 times 1 divided by 2 times 1, and those cancel, so I get 12, which is what I had counted below. Alright, so that's a nuance that I'll draw your attention to later, and it's in a future video, but it's actually very important, so just keep it in mind.